Welcome, dear listeners, to History with Herodotus, where we embark on a journey through the ages, unraveling the mysteries of our collective past. Today, we find ourselves at the threshold of a most fascinating tale, the origins of alchemy and the foundations of chemistry. As we delve into this captivating narrative, let us first set the stage for the enchanting story that is about to unfold. In the realm of human curiosity, few pursuits have captivated the imagination as thoroughly as the quest to understand the fundamental nature of matter and the secrets of transformation. Alchemy, with its promise of transmuting base metals into precious ones and uncovering the mysteries of life and death, has long been a subject of intrigue. The foundations of chemistry, rooted in the observation and experimentation of ancient civilizations, laid the groundwork for our modern understanding of the elements and their interactions. As we venture back in time, we find ourselves in ancient Mesopotamia around 2500 BCE, where the Sumerians were experimenting with the properties of metals and minerals. The discovery of clay tablets from the library of Ashurbanipal in Nineveh, dating back to around 650 BCE, reveals a wealth of knowledge about metallurgy, including the production of glass and the use of various alloys. These early endeavors demonstrate a deep understanding of chemical processes and the properties of various substances. In ancient Egypt, around 1500 BCE, we find evidence of advanced knowledge in metallurgy and the production of pigments. The Edwin Smith Papyrus, an ancient medical text, contains recipes for the creation of various compounds, showcasing the Egyptians' understanding of chemical reactions. The tomb of Tutankhamun, with its elaborate funerary mask, testifies to the sophistication of Egyptian metalwork and their ability to create complex alloys. As we journey further east, we find that the ancient Chinese were also experimenting with the properties of matter. The discovery of the oldest known piece of glass, dating back to around 2000 BCE in the tomb of a Chinese noble, demonstrates an early understanding of chemical processes. The works of Chinese alchemists such as Wei Boyang, who wrote about the principles of transformation and the creation of elixirs, laid the groundwork for later alchemical thought. In the Mediterranean, the teachings of Greek philosophers such as Empedocles and Aristotle provided a philosophical framework for understanding the natural world. Empedocles' concept of the four roots, earth, air, fire, and water, which he believed were the fundamental building blocks of the universe, laid the groundwork for later theories about the nature of matter. Aristotle's ideas on the transmutation of elements, as expressed in his work, Meteorology, further contributed to the development of alchemical thought. By the 5th century BCE, in the vibrant city of Alexandria, we witness a confluence of knowledge from Egypt, Greece, and the Middle East. This cosmopolitan center of learning became a crucible for alchemical thought, where scholars like Zosimos of Panopolis began to systematize practices and theories that would influence generations to come. The works of Zosimos, which include treatises on metallurgy and the production of dyes, demonstrate a deep understanding of chemical processes and the properties of various substances. As we explore the earliest history of alchemy and the foundations of chemistry, we find ourselves immersed in a world of curiosity and discovery, where scholars and practitioners from diverse backgrounds contributed to a rich tapestry of knowledge. The contributions of these ancient civilizations laid the groundwork for the evolution of alchemy and the development of modern chemistry. In this era of great change, which spans from the 16th to the 18th century, we find ourselves amidst a whirlwind of discovery and innovation. The Renaissance, with its revival of classical knowledge, sparked a renewed interest in alchemical pursuits. Figures such as Heinrich Cornelius Agrippa and Paracelsus made significant contributions to the field, pushing the boundaries of understanding about the properties of matter and the potential for transformation. One of the most pivotal figures of this era was Sir Isaac Newton, whose work on optics and physics laid the foundation for a deeper understanding of the natural world. Though often remembered for his contributions to mechanics and universal gravitation, Newton was also an avid alchemist, believing in the possibility of transmuting base metals into gold. His manuscript, Index Chemicus, reveals a thorough familiarity with alchemical texts and practices, demonstrating how even the most influential scientists of the time were not immune to the allure of alchemical pursuits. As we delve deeper into this period, we find the emergence of key figures who would bridge the gap between alchemy and modern chemistry. Robert Boyle, often regarded as the father of modern chemistry, conducted extensive experiments on the properties of gases and the behavior of elements. His book, The Skeptical Chemist, published in 1661, marks a significant turning point in the history of chemistry as it begins to separate the discipline from its alchemical roots, advocating for a more empirical approach based on experimentation and observation. In parallel, the work of Antoine Lavoisier in France during the late 18th century further solidified the foundations of modern chemistry. His discovery of oxygen and his role in dismantling the phlogiston theory of combustion were instrumental in establishing chemistry as a distinct scientific discipline. The meticulous experiments and the systematic approach of Lavoisier set the stage for the chemical revolution, marking a clear shift away from alchemical theories towards a more rational understanding of chemical reactions and elemental properties. The contributions of these pioneers, along with many others, transformed the landscape of knowledge regarding matter and its transformations. As alchemy gradually gave way to chemistry, the discipline became more refined, with an increasing emphasis on empirical evidence and systematic experimentation. This era saw not only the laying down of the principles that would govern chemical thought for centuries to come, but also the establishment of institutions dedicated to scientific inquiry, such as the Royal Society in England. The intersection of alchemical aspirations with the burgeoning field of chemistry during this period is a testament to human curiosity and the relentless pursuit of understanding. It was an era marked by both a reverence for ancient wisdom and an eagerness to challenge prevailing beliefs through experimentation and observation. As we witness the evolution of alchemy into modern chemistry, we are reminded that scientific progress often results from the interplay between tradition and innovation. The legacy of alchemy, though it may seem distant and even mystical to us today, played a crucial role in shaping our understanding of the material world. In this era, we find the rise of prominent chemists such as John Dalton, who introduced the concept of atomic theory, proposing that elements are composed of small, indivisible particles called atoms. This groundbreaking idea laid the foundation for modern chemistry, allowing scientists to better understand the properties and behavior of elements. Another key figure of this period was Michael Faraday, whose work on electrochemistry led to the discovery of the laws of electrolysis. His experiments with electricity and chemical reactions revealed the intimate connection between the two, paving the way for the development of new technologies and a deeper understanding of chemical processes. The 19th century also saw significant advancements in organic chemistry, particularly through the work of Friedrich Wöhler and Auguste Laurent. Wöhler's synthesis of urea from inorganic compounds challenged the long-held belief that organic substances could only be produced by living organisms, while Laurent's work on the theory of radicals helped to establish the foundation for modern organic chemistry. As we explore this period, we notice a gradual decline in alchemical pursuits, as scientists began to favor more rational and empirical approaches to understanding the natural world. The establishment of institutions such as the Royal Society and the French Academy of Sciences provided a platform for chemists to share their findings and collaborate on research, further solidifying the discipline's reputation as a rigorous and systematic field of study. However, despite the advancements in chemistry, remnants of alchemical thought persisted, particularly in the realm of spiritual and philosophical inquiry. The ideas of alchemists such as Emanuel Swedenborg and Samuel Taylor Coleridge continued to influence artistic and literary movements, demonstrating the enduring appeal of alchemical symbolism and mysticism. As we approach the end of the 19th century, we find that chemistry has become a distinct and respected discipline with its own methodologies, principles, and applications. The legacy of alchemy, though no longer a dominant force in scientific inquiry, continues to inspire and influence various aspects of culture and society. In conclusion, our journey through the history of alchemy and the foundations of chemistry has brought us to the threshold of the modern era, where chemistry stands as a testament to human curiosity and ingenuity. As we reflect on the contributions of pioneers such as Dalton, Faraday, and Wöhler, we are reminded that scientific progress often results from the interplay between tradition and innovation. The story of alchemy and chemistry serves as a powerful reminder of the human pursuit of knowledge and the transformative power of scientific inquiry. That's all for today's History with Herodotus. Remember to like, share, and subscribe, and until next time, remember that to understand the present, we must first understand the past.